Hey everybody, welcome back to more learning with about factoring and factoring trinomials. So this top part here is kind of like some nonsense problems, but if you notice, they're all trinomials. And so what we're going to do with these is we're just going to look at the signs of all the terms and try to decide what would be the correct signs that I would have to put into my factors to make it work. So remember, it's the very last term. So it's the very last term, the sign of the last term, that helps us determine what signs go in. So if you look, this last term is negative syrup. And even though we don't know what number that is, we know since it's negative, we have to multiply to get the last term always. So when the last term is negative, that means the signs have to be different, right? So in this case, we're going to write in here plus minus, plus minus. It could be minus plus, but that all depends on what we're trying to get as our middle term, right? And what you have anywhere. So it's just as long as you understand that the signs there have to be different. In the next one, the last term is positive. So when the last term is positive, that means the only way to get a positive is that you're multiplying two things with the same signs. So we could do a positive times a positive, but in this case, because the middle term is negative, it has to be a negative times a negative. So the only signs that can go in this one are minus, minus, right? And it depends on the middle term, right? So if the last term is positive, then that means your signs have to be the same. And if everything in the problem is positive, then the signs have to be plus plus. But if the middle term is negative, because remember, to get that middle term there, you're multiplying your outers, you're multiplying your inners, but then you're combining them together. So if you're combining two things that are both negative, then it's going to stay negative. So I want you to stop the video right now, and I want you to go through and see if you can figure out what the signs would be, and then come back to make sure you've got it. All right, I hope you actually stopped the video. Check to see if your answers are right. Notice on any ones where the signs are different, I wrote that you could be plus minus or minus plus. You don't have to put them both down. I just want to reiterate that it doesn't matter really what order the minus and the plus go in. It depends on what your middle term actually is. And since we don't know what these numbers are, then it doesn't matter right now what order they go in. All right, so we actually spent 2 different days talking about 2 different kinds of factoring. The first kind was, we learned in Concept 20, was just one way to factor is just by pulling out a GCF. So if I were to do that, just as a reminder, I'm going to look at both of those terms here, and what is my GCF? Well, 36 and 20, they both have 4 in common, and they don't have any x's in common. They would both have to have an x in common, but they do have 3 y's in common. So my GCF is going to be 4y to the third. And so then I would put in parentheses 9x plus 5y to the second. And that would be, again, just a reminder of factoring by GCF. But then in Concept 21, we learned, well, not everything has to have a GCF. If you've got trinomial, you can factor it into 2 sets of parentheses into 2 binomials. And so then you just play around with it. 6x squared, we could try 3x and 2x. And then we're going to look at the last term of 4. We could try 2 and 2, or we could try 4 and 1. And so feel free right now to stop the video and see if you can get it. So I've determined that the signs here both have to be addition because the last term is positive. And when I broke it up into 2 and 2, it didn't work. So then I tried 4 and 1. And if you put the 4 right here and the 1 right here, and you tried your outers and your inners give you 8x, and your outers give you 3x. And if you combine 8x and 3x, you are getting 11x in the middle. And so that would be 3x plus 4 times 2x plus 1. So now today we're going to talk about combining both kinds of factoring. So what I want you to do right now on your own is I'm going to have you stop the video, and what I want you to do is I want you to factor the left-hand side on your own, okay? Over here we're going to factor them together, but I want you to just factor this right now into 2 binomials. So do not pull out a GCF right now. Just go through, put your 2 sets of parentheses, and factor it, and try to get 36x for your middle term, okay? Same down here. Go ahead and try it. And then come back to the video and watch it. Alright, so now if you did these problems and then compared your answer with other people in the class, you're going to find that the very first problem actually has 4 different ways you can factor it. Look at these 4. Is one of your answers there? If it's not, either I missed one or yours isn't working, but I'm pretty sure I didn't miss one. There are 4 there. If you did this one, there are 2 possible answers that you could have come up with. Now, we know that we don't like to have multiple answers in math. We have to have one answer. And so that's why pulling out a GCF should always be our first step. So this is the thing that we're going to now have to train our brains to do. When we look at a trinomial now, or any polynomial when you're asked to factor, the very first thing that you're going to try to do is pull out a GCF. So now if you look at this problem, we're going to pull out the 6 in the very first problem. So I'm going to go ahead and I'm going to write a 6 down, and I'm going to pull out a 6 out of this. And when I pull out the 6, I'm left with x squared plus 6x plus 5. And then from there, the 6 is still a factor, so I'm going to write down my 6. And then this is a trinomial, and that trinomial can now get factored into 2 sets of parentheses. And it's a lot easier actually, because there's only one way to break up x squared, that's x and x. And there's only one way to break up the 5, that's 5 and 1. And now look, my outers and my inners, because I pulled out the GCF, I'm now trying to get 6 in the middle. So my inners are 5x, my outers are x, and 5x and x give me 6x, right? So if I went through, so this is my answer right here, the whole thing including the 6. Now, if you wanted to check this problem to see if you were right, we actually did 2 steps. So it's going to be 2 steps to get back to my answer, right? If I went through and I did FOIL with this whole thing right here, x times x is x squared, x times 1 is x, 5 times x is 5x, that gives me the 6x, 5 times 1 is 1, gets 5. But now we pulled out the 6, so then you distribute that 6 back in there, and that brings us back to this. So if you're checking your answers, FOIL this, distribute the GCF that you pulled out back in, and it brings us right back to this. Okay, so this problem actually has 3 possible factors. So now, if you forget to pull out a GCF, you can fix it. So let's go over here and look at all of these problems. In this one, these aren't right because there's a GCF in this set of parentheses and in this set of parentheses. So look, the GCF here is a 3. So if I take that problem and I pull out the 3, what I'm left with is x plus 1, right? If I look at this problem, my GCF is 2. So if I pull out the 2, I'm left with x plus 5. Now look, all of this is being multiplied together. So if I multiply now the 3 and the 2 together, that gives me the 6, right? And then you have your factors x plus 1 and x plus 5. So look, this actually does match that. So this could get translated into that. Same with the next one. If I look at my first set of parentheses, that has a GCF of 6. If I pull the 6 out, I'm left with a 6 on the outside, x plus 1. There is not a GCF in the x plus 5, but look, this matches that. It's just in a different order. It's fine. This one has a GCF of 3. So if I pull that 3 out, I'm left with x plus 5. If I pull a 2 out of the second set of parentheses, I'm left with x plus 1. If you put the 3 times the 2 together, that gives you 6. That's going to end up giving you that answer. This one, pull out a 6, because that's your GCF, and you're left with x plus 5. The second set of parentheses doesn't have a GCF, so I just have that x plus 1. That matches, okay? Same with the next problem. Go ahead and look. Let's look at factor with me. What's the GCF? There's a 7. A 7 goes into 14, 49, and 21. So I'm going to pull out the 7. When I pull out the 7, I get 2x squared minus 7x plus 3. And now this problem becomes much easier to factor once you pull out the 7. The 7 is still a factor. Then I'm going to break up the trinomial, the 2x squared minus 7x plus 3. The only way to break up 2x squared is 2x and x, and the only way to break up 3 is 3 and 1. My signs both have to be negative. And now if you think about it, before I place my 3 and my 1, if I place my 3 here, this is going to give me 3x and 2x. Well, that doesn't give me negative 7. If I put the 3 right here, the 3 is going to get multiplied by the 2. Well, 3 times 2 is 6. If I put a 1 here, well, 6 and 1 gives me 7. And they're both negative. So I'm going to put the 3 right here and the 1 right here. And there you go. Now I've got it. This is the fully factored problem. That's something that's factored completely. Now if you go over here to the left again, if you look, this first set of parentheses has a GCF in it. It has a 7 in it, right? If I pulled that 7 out, I would be left with 2x minus 1, and then you have the other factor of x minus 3 next to it. That's the same answer. Over here, there's not a GCF in 2x minus 1, but there is a GCF in 7x minus 21. So if I pull out the 7, I'm going to be left with the x minus 3, and then I'm bringing down that 2x minus 1. And I just realized I made a mistake over here. That should be a plus sign. Whoops. Okay, so there you go. And that's what we're going to do now. We are always going to look for a GCF, and then we're going to factor from there. So let's take a look at the next set of problems. So the conclusion that we can make by doing the problems that we just did is that you can actually take out your greatest common factor at any time, but it's always going to be easier if you pull out your GCF first, because then you have less numbers you have smaller numbers to work with and less things to try. So now we're going to try to train our brain that when you see the directions factor, then what you do is you look at the problem and you ask yourself first, is there a GCF? If yes, you pull it out, and then we divide it out. Now, the thing that's important is that the GCF, it is still a factor. You can't get rid of it. It's still a factor. And then you try to factor it into binomials. If there's not a GCF, then you don't pull out the GCF. You just go straight into factoring into binomials. So let me do the first one with you. First question, is there a GCF? And the answer to that is yes. Yes, there is a GCF. What is the GCF? Well, looking at 4, 20, and 24, I'm going to say it's 4, right? 4 goes into all of those numbers. And then you also have a bunch of variables to work with here. They all have an x. Nope, I'm wrong. They all have y squared in common. So the GCF is 4y squared. And so what we're going to do is we're going to write down the GCF of 4y squared, and we're going to divide it out. And so when I divide each term by 4y squared, I'm going to be left with x squared minus 5x plus 6. And then the next thing I'm going to do is I'm now going to factor into binomials. That GCF, however, is still part of your answer. Don't get rid of it, or your whole answer is going to be wrong, right? And so now I am factoring this part, okay? So x squared, the only way to break up x squared is x and x. We know our signs have to be the same because the last number is positive, and they both have to be negative. We can try 3 and 2. We can try 6 and 1. So if you think about it, if I put a 3 here and a 2 here, my inners right here is 3x, negative 3x, and then negative 2x. And negative 3x and negative 2x does give me negative 5x. And that is the fully, completely factored answer. You can check your answer by doing FOIL with this. FOIL with this will bring you to this, and then you distribute your 4y squared into that, and it will bring you back to your original problem. So now stop the video and try the next two on your own, and then chime back in, make sure that you've got them right. Okay, so now if you look, I pulled out my 6x, I was left with that, I factored this into this. I knew, again, just a reminder, that my last term, since my last term was negative, I knew my signs had to be different, right? And so I knew that when I went to do my outsides and my insides, the signs were going to be different, so it's almost like I'm subtracting or I'm canceling x's out. So here, if you check your inners, that's negative 6x, this is positive 5x, and negative 6 plus 5 does give me negative 1 in there, so negative 1x. Don't forget to put this as part of your answer. It's still a factor. In the next one, 2 was my GCF. I was left with this trinomial. I factored this trinomial into these two binomials. I brought my 2 straight down. check your outers and your inners. The inners give me 2x, the outers give me 25x, and 25x plus 2x gives me 27. I knew both my signs were going to be plus plus because my last term is positive. Okay? Now let's look at the next set of problems. So the next set of problems are asking you to factor completely. And you're going to pull out a GCF if there is one, and then you're going to factor into binomials. Now, they're both types here. Some things don't have a GCF and some things do. So I'm going to go ahead and do the first one with you. And because I want to remind you, remember when I said that we're never going to break up the first term into negatives, a negative times a negative or a negative times a positive? The reason for that is because when that first term is negative, remember, we're always going to pull out a negative GCF. So just a reminder on that. This one's going to have a negative GCF. Number 6, we're going to pull out -1 from here. We always want our x squared term to be positive. Always, 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 always. So that's why we always want our very first term to be positive. So we're going to pull out a negative number. So if we look at number 4, first thing that we're going to do is we're going to pull out a -2. Because they all have 2 in common, and since we want x squared to be positive, we're going to divide out a -2. And remember, when you divide everything by a negative, that changes all the signs. So -2x squared divided by -2 is positive x squared. 42x divided by -2 is -21x. And -216 divided by 2 is positive 108. Sorry, divided by -2 is positive 108. And so now the next thing that I'm going to do is I'm going to bring down my -2, and then I'm going to start playing around with factoring. So x squared, there's only one way to break up x squared. That's going to be x and x. And then I'm going to look at 108. And I know that my signs are going to have to be the same because that's the only way to get a positive at the end. And I know they both have to be negative because that's the only way to get a negative middle term. So I'm going to play around with factors of 108. There are many factors that go into 108. You do 2 and 54. We're trying to get -21 though. So think about it. Whatever I put here and here, they're both going to get multiplied by an x. So honestly, when you're breaking something up into x and x, you're really coming up with two things that multiplied to give you 108, but add to give you -21. So if you play around with some numbers, you're going to find 108, 9 goes into that 12 times, and isn't 9 and 12 21? So it's going to be x minus 9 and x minus 21. And that is a fully factored answer. Don't forget your GCF is part of your answer. If you forget your GCF, then the whole thing's wrong. All right, I want you right now to stop the video, and if somebody else at your table is finished working, then maybe you all could work together on these problems. Once you're finished, or if you're confused about a problem, then come back in and chime in and see if you've got the right answers. So here are the answers for problems 5 through 9. Things that people forget is that sometimes your GCF is only a variable, right? So here we only put on an AB. In number 6, we had to pull out -1 because the first term was negative. Number 7 didn't have a GCF, so we just factored it into binomials, right? So that's possible. And then I want to point out for 8 and for 9, we pulled out a negative GCF, and then when we factored into two of the same things. So this factored into the square of a difference, which I could write like this. You don't have to write it like that, but sometimes you might see the answer written like that. That means this thing happened twice. Same with this one. This factored into the square of a sum, and so I wrote it like that. But you probably just wrote that. I just want you to be aware that the answer could be written like that. Now, if you still need the answer, if you haven't done 10, 11, and 12, you need to do them before you check in for the answers. And here are the answers to the next 3. Again, notice number 11 didn't have a GCF, so I just factored it into binomials. If you're confused on any of these problems, please be sure that you seek help. And if you're good, then you should start your homework. Good luck.